But we are not going to stop there. We're going to roll right now into the non-multiple choice one. So question 11, Michael buys a car for $20,000. He sells it a year later and it's gone down in value now to $16,000. What's the percentage decrease in price? So let's have a look. He's lost $4,000, hasn't he? He bought it for 20, sold it for 16, so it's come down in price by 4,000. So we're going to do a little percentage question here, and if I can get this to work, 20,000 times some percentage. We don't know what that is yet. That's what we're working out. Let's call it P equals 4,000 because that's how much it came down. So 20,000 times some percentage gets us to 4,000. Now I can use my algebra to solve for P, so I divide both sides by 20,000 so that the 20,000s here cancel out. P equals 4,000 over 20,000. Stick that in your calculator and you get a value of 0.2. Now that's a decimal, so to get it back to a percentage, we multiply it by 100, 20%. It was a 20% decrease in value. Question 15, we're buying a car. Congratulations, $30,000. I don't know that I've ever paid that much for a car. Maybe one day, who knows? Here are some options. You can just buy it straight up for $30,000, or if you don't have enough, you're going to have to use what we call, remember, financing. So you're going to pay a 20% deposit, and then you're going to have monthly repayments of $850 for 5 years. So how much will the car cost you all up if you use the finance package? Well, let's have a look. There's two parts to it, isn't there? There's the deposit, which we'll pay up front, and then there's the repayments that we make over 5 years. So let's do the deposit bit first of all. It is 20% deposit, so 20% of this purchase price. So in other words, 30,000 times 0.2, because remember we take the percentage and we convert it to a decimal, equals 6,000. So we're going to pay 6,000 straight up front. Now we're going to then pay off over 5 years. So every month, right, because it's monthly repayments, we're going to pay $850. There are 12 months in a year, so I multiply that to get an amount per year, and we're doing it for 5 years, so times it by another 5. $850 a month times 12 months times 5 years means that over that 5-year period, we're going to pay off $5,100. That's not right. $51,000. $51,000. Okay. So how much have we paid all up for the car? Well, I've got to add those two together, don't I? I paid the $6,000 up front. Over 5 years, I paid another $51,000. So in total, I've paid $57,000 for the car. Now, how much interest have I paid? Well, the interest is just the difference between what I've paid in total minus what I could have paid if I just bought it straight up without any finance. So we paid $57,000. The actual cost of the car was only $30,000. The difference must be the amount of interest that we've paid. So $27,000 interest. Sienna filled her car with petrol. When she filled it up, the odometer, which is the little thing that tells you how many kilometers you've done on the dash, was at this number here. It's a big number. I'm not going to say it. When she filled it up, next, it was this number here, another big one. I'm not going to say. So, and when she filled it up, there were 53 litres of petrol that went in. So, first of all, how far has the car travelled? Well, it's the difference between these two numbers. This big number, 65,850 minus 65,055. Stick it in your calculator, and you can see that from the first fill up to the second one, she's travelled 795 kilometres. So what was the fuel consumption in litres per 100 kilometres? Now, remember, our fuel consumption formula is just the amount of fuel used, times it by 100, and divide it by the distance. Well, you can put some of those values in because we've got 53 litres is our fuel used, and we've got a distance. It was 795. I can just plug those values in. 53 litres times 100 divided by the 795. Put it in your calculator and you get a value of 6.67. So for every 100 kilometres she drove, she used 6.67 litres. That was her fuel consumption. Here's a budget for someone. We don't know who it is. But this is a list of their incomes. In other words, money that comes in. Income comes in. Yeah, hopefully that makes sense. And expenses are things that they spent on. expenses. Spend. I don't know. Maybe that helps. Calculate their income. Well, you might have multiple sources of income if you're lucky. They've got a salary, which is their job, what they get paid for, and they've got some interest from an investment somewhere. So all of that counts as money coming in, income. Add it together, and you get a yearly income of 63,315.25. Expenses, same deal. We're just going to go through and, oh man, I tell you, this actually took me a little while with the calculator. Just adding up all of these numbers, and the yearly expenses come to. Yeah, listen, I don't know what happened here, so I'm sorry about this big white blotch on the screen. But anyway, it adds up to this number, 61562.83. So that's the expenses. Now the balance, to balance the budget, the income and the expenses have to add up to be the same. So we need to come up with a number that I can add to this expenses side to bring it into balance. And it is simply the difference between the two. My expenses were... my income was this, my expenses were this, the difference, which is savings, okay, because I've got more money coming in, and I'm just looking at those numbers, they don't look right. Okay, I've messed up here, so but you can fix it because you're smart. So it's much more than 175, it's something else. Anyway, I messed up. You can fix it up, but whatever the actual difference is between those two, that would be the balance because it brings it into balance. I'm just going to move on because that's embarrassing. Question 15. Amelia earns $95,000 annually. That means every year. Annual means yearly. So she's budgeted 25% of that for a loan repayment. So how much will she put aside for her loan repayments? Nice and easy question, this one. I just take the 25%, turn it into a decimal before we use it by dividing by 100. Gets me to 0.25. Now, all I'm going to do is multiply this by her annual income. 25% of her income works out to be 23,750. I feel a little more confident, like this number hopefully makes more sense than the one before, so I'm going to stick with that. Christian is a courier who delivers one parcel on average every 25 minutes. So how long to deliver 22? I'm going to do this two ways because there's an easy way because it's kind of not a tricky question. But then I'm also going to use my favorite, like cross-multiplying stuff to just back it up. So let's do it the nice easy way first. If it takes him 25 minutes to deliver one parcel, then there's 22 of them, so I just multiply those together. 25 minutes every parcel times 22 parcels comes to 550 minutes. Don't forget to read the question though, because it says how many hours. Now, if you gave an answer in 550 minutes, you haven't fully answered the question because they want the answer in hours. So I'm going to convert this to hours. Now I know that there are 60 minutes in an hour, so just divide this by 60 to get 9.17 hours. Just to prove it, that my favorite methods actually work, I'm going to do it this way. Parcels per hour equals 1 per 25. One parcel per 25 minutes. So 22 parcels per some number of minutes that we don't know. Stick in an X. I'm excited because I get to cross multiply across the equal sign. I got two fractions with an equal sign. 1 times X is X. 25 times 22 is 550. So my X, just like we did before, 550 minutes. You can take it from there. It's just then converting that into hours. So yeah, it worked. Convert each rate. I'm going to go through these. A little bit of work to be done here, but they're not that hard if you just slow down and take your time. Let's write this $15 per kilogram. It's dollars per kilogram. 15 per 1. My answer, though, is going to be dollars per gram because it's asking to convert it to dollars per gram. Having a look, do I need to convert the top? No, dollars to dollars. I don't need to do anything with the top, so I'm going to leave it as is, 15. Per, now, the bottom, though, I do need to. I've got to go from kilograms to grams. So if I can't remember, I'm going to draw up my little conversion chart. And I know that if I'm going from kilograms to grams, I multiply by 1,000. So my 1 becomes 1,000 because now this is grams. 1 kilogram is 1,000 grams. All right. Let's take that, stick it in your calculator, 15 divided by 1,000, and you get $0.015 per gram. We've now converted that down into a rate per gram. So the next question is basically the same idea. We've got minutes per hour, right? That's what we start with, and we're converting it to meters. Sorry, rewind. Let's rewind. All right, let's do it. Okay, meters per hour, and I'm converting it to meters per minute. So do I need to convert the top? No, it's in meters. It's staying in meters, so just stick the number in. Not a problem. The bottom, though, is going from hours to minutes. So my little conversion chart here, I know that if I'm going from hours to minutes, I have to multiply by 60. So 1 times 60 means there are 60 minutes. Now, it's written in meters per minute. Stick that in your calculator, you'll get a value of 175 meters per minute. Congratulations. This one is a little funky because there's conversions got to be done on the top and bottom. Don't freak out. It's the same process. It's just we're going to do it in 2 separate parts. We've got 11 liters per gram, right? Liters per gram, 11 per 1. But what we want to end up with is milliliters per kilogram. So as I have a look, I'm going to have to convert the top. Let's do the top first of all. Liters to milliliters. I know that that's times by 1,000. Okay, converting liters to milliliters, I times it by 1,000. So I've got 11,000 on the top. I've done the conversion. 11 liters is 11,000 milliliters. Now, I'm going to do the same thing. I'm going to convert the bottom because I've got to go from grams to kilograms. And I'm going to do my little conversion chart here. I know that when I'm traveling from grams to kilograms, my action or my calculation is divide by 1,000. So I'm going to take 1, divide it by 1,000, and I get 0.001. Put that in, and now I've converted 1 gram to 0.001 kilograms. Now, just like we did before, stick that in your calculator, and you're going to get 11 million pop out. There are 11 million milligrams per kilogram. Milliliters, per kilogram. Okay, if there's 11 liters per gram, that's the same thing as 11 million milliliters per kilogram. I know those numbers got a little bit big and funky, but hopefully you saw the process was just the same. I just had to do the top, then the bottoms. Whew. 18. Okay, simplifying ratios. So just like simplifying equivalent fractions, I'm looking for a highest common factor that I can divide into both sides of the ratio. So having a look here, I can see these numbers are kind of pretty easy to work with. 50 and 400, I can see that 50 actually fits into both of those. That's my highest common factor. It's the biggest number that'll fit into 50. So I'm going to divide both sides by that highest common factor. Okay, 40 divided by 50 gets me 8. 50 divided by 50 gets me 1. So 8 to 1 is my simplified ratio. 400 to 50 is exactly the same ratio as 8 to 1. They're the same thing. They're equivalent ratios. Let's do the same thing now. You'll notice in this ratio, jumped ahead. You'll notice in this ratio there's 3 values, 10 to 8 to 12. So I've got to find the highest common factor that fits into all 3. Because if I look at 8 and 12, yeah, I know 4 fits into both of those, but 4 doesn't fit neatly into 10. So let's go with 2. I know 2 will fit into each of those. So I'm going to divide every single one of them by 2. 10 over 2 is 5, 8 over 2 is 4, 12 over 2 is 6, so 5, 4, and 6 is my simplified ratio. Hey, C is a little bit funky because it's now got decimals in there, and that looks a little weird. How do I start thinking about highest common factors with decimals? That's just going to be too much work. So make it easy for yourself. Convert these into whole numbers by simply multiplying by 10, because as you see, when we multiply by 10, remember when we multiply any number by 10, the decimal point moves one place to the right. So if I multiply them both by 10, those decimal places both move along. So 5.2 becomes 52, 1.3 becomes 13. Now, is there a common factor? Well, 13 is a prime number. So there's only two factors, 1 and 13. So I'm going to see, does 13 fit into both of those numbers? Let's have a look. If I try and divide both sides by 13, it actually does. 52 divided by 13, if you're not sure, you can put it in your calculator, will come out at 4 to 1. So there were two steps there. Multiplying it by 10 to get these decimals undone, and just so we know we're working with whole numbers, and then look for the highest common factor. We're nearly there. Question 19. Daniel and Eddie own a business, and they share the profits in a ratio 3:5. So who gets more of the profits? Eddie does, because remember, ratios are written in the way that the question presents them. Daniel and Eddie. So this will be Daniel and Eddie, 3:5. Now, as I add up the 3 plus 5, I can see in total there are 8 parts to this ratio. 3 of them for Daniel, 5 of them for Eddie. 8 in total. So I'm going to take the profit for the week, the 5,000, I'm going to split it into 8, because there are 8 parts in total. So if I divide that by 8, every part is $625. Now, Daniel gets this side, the smaller side, because his name was first, Daniel and Eddie. Right? So the ratio here is Daniel to Eddie. Daniel gets 3 parts, and we decided one part was $625. So if I times that by 3, he's going to get $1,875. So his share of the $5,000 profit is $1,875. Question 20. Maps. Scale on a map is given 1 centimeter equals 5 kilometers. If on the map they're 44 millimeters apart, what's the actual distance? Now this gets a little bit weird, this one, because we've got 3 different units. Don't want that. That's going to get weird and confusing. So we're going to do our ratio as 1 to 5. Okay. Map over real equals 1 over 5, right? That's what we've got here. The map is 1 centimeter. In real life, that's 5 kilometers. So map over real equals 1 centimeter over 5 kilometers. We're going to duplicate that now, but before we do anything, I'm going to get rid of this millimeters because I'm working with centimeters and kilometers. I'm going to convert this to 4.4 centimeters. Okay, there are 10 millimeters in a centimeter. So 44 millimeters is 4.4 centimeters. Now I can work with just centimeters and kilometers. So map over real equals map over real equals map over real, which we don't know, so call it X. You know what's coming. You know what's coming. We're cross multiplying. X times 1 is X, and 5 times 4.4 gets me an X value of 22. Now remember that we had centimeters over kilometers, so the number on the bottom here was a kilometer value. So in real life, it's 22 kilometers. And you know what? Just stop at the end of a question and think, does this make sense? Well, if 1 centimeter was 5 kilometers, 4 and a bit centimeters is going to be, maybe 4 and a bit times 5, which is 22. Because if you do 4.4 times blah, 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 you got it. Okay. House plans, no real secrets here. Just trying to know what some of the symbols are. But if you get stuck, use some common sense and just think about it. Which one represents the shower? Think about a house. Is there a shower in the toilet? No. Is there a shower in the laundry? Sometimes, but not usually. It's usually in the bathroom. So this looks like a bath. This looks like a sink. This must be you got it, a shower. So the symbol for the shower was this square with a cross in it. So even if you just didn't know that, you could kind of just using common sense figure it out. Doors are represented by these lines. Wow, I don't know what happened there. Sorry about that. But these lines with a little curve here that represent like the door opening are doors. So there's one here into the toilet, one into the bathroom, one into the laundry. Don't count the wardrobe doors because that's just being silly. We want to count the doors. I know technically that's a door, but anyway. There are 3. All right, if the longest internal wall for the toilet is 2 meters, what's a scale for the drawing? Now, you are going to have... Now, this might be different for you because I'm doing this on a screen anyway. My point is this. The toilet, which is this one here. I know it doesn't say toilet. It says WC. WC is short for water closet, which is a weird name for a toilet. The longest internal wall. So that's this bit here. It's the longest wall. Great, because here's my toilet. This is the longest wall. The internal bit means I'm measuring the inside of the wall. So from here to here. Now, get your ruler out and measure it. You're going to have to actually physically measure it on your test paper. Let's say it works out to be 40 millimeters on my diagram. Yours will probably be different, but let's say it's 40 millimeters. Now I've got something to work with because now I've got a scale. I've got a ratio. Map to real is millimeters to meters is 40 to 2. 40 millimeters on that I measured is 2 meters in real life because we're told that if the wall is actually 2 meters. Map to real equals 40 to 2 millimeters to meters. Yeah. Now, our answer though is having to... Okay, I got a bit confused there. I circled this because this is not a ratio. Remember, ratios use the same units. This is different. This is millimeters per meters. So I'm going to have to convert this to millimeters. Okay, I hope that made sense. Remember, a ratio has the same units. A rate has different units. So I've got 40 millimeters over 2 meters. They're not the same. So I'm going to have to convert this one to millimeters. And we've done this before in a previous question. Okay, the 40 stays the same because I'm millimeters on the top, millimeters on top. I don't need to change it. But meters to millimeters, using my little conversion chart, I'm going to go times 100, then times another 10, gets me 2,000. So on the bottom, I've now got 2,000. So it's 40 millimeters to 2,000 millimeters. Now that's a ratio. So I'm going to write that as a ratio, 40 to 2,000. And like we did before, when you simplify, I'm looking for the highest common factor. I can see that 40 fits into both of those numbers. So if I divide them both by 40, I get a ratio of 1 to 50. That is our scale, 1 to 50. In other words, 1 millimeter in map distance will be 50 millimeters in real distance. Yeah, hope that makes sense. Last question. Hey, this is a funky question. Buckle up. We're going to do a little bit of algebra, a little bit of problem solving, and it's pretty cool. Here we go. Pump A can fill a tank in 5 minutes, but pump B can fill a tank in 10 minutes. So pump A is a faster pump, yeah? It only takes 5 minutes to fill the tank, whereas pump B takes 10 minutes. But if we had them both coming into the tank together, how long would it take to fill the tank? All right, here we go. We're going to write these out as rates. Pump A has a rate of 1 tank per 5 minutes. Pump B has a rate of 1 tank per 10 minutes. Okay, that's just from the info up here in the question. They're both coming into the tank at the same time. So they're added together, don't they? This is what's coming into the tank, right? I've got pump A coming in at 1 tank per 5 minutes. Tank B coming in at 1 tank per 10 minutes. Now my answer, I'm looking for 1 tank per some number of minutes. We don't know. That's what we're trying to figure out, okay? Tank per minute. My answer is going to be 1 tank per some number of minutes. I'm going to pause here because hopefully you can see how I've constructed this algebraic equation from my facts here. 1 tank per 5 minutes plus 1 tank per 10 minutes. Add them together will give me 1 tank per some number of minutes. Now, solving this, maybe it gets a little bit scary. It looks a bit scary, but it's actually not that bad. Let's convert this bit, the 1/5, to a common denominator with 10 on the bottom. So to do that, I just multiply both the top and the bottom by 2, because 1/5 is the same thing as 2/10. Now I can add these together, can't I? I've got 2/10 plus 1/10, and I haven't touched the other side yet. So 3/10, 3/10 equals 1/x. For the last time, and I told you this crops up a lot, we're going to cross multiply because I've got two fractions separated by an equal sign. 3 times x equals 10 times 1. 3x equals 10. We are one step away from cracking open this awesome question. Divide both sides by 3 so that 3's cancel out. X equals 10/3, or 3 1/3 minutes. If you put both pumps into the tank together, it'll take 3 1/3 minutes. Now, once again, just before we wrap up, does the answer make sense? Yeah, of course it does. If pump A can do it in 5 minutes on its own, and you start adding another pump, your answer is going to have to do less than 5, isn't it? I've seen people write answers to this quite a bit at 7.5 minutes. But think about it, that makes no sense. Pump A can do it on its own in 5. So anything we add to that is going to fill it quicker. So my answer is going to have to be less than 5. Is 3 1/3 less than 5? Yes, it is. Congratulations. There was a lot to go through. But hopefully you guys have got something out of all of that. Well done.